All right, good morning. All right, what I'm going to talk about this morning is just some of the myth busters, if you will. I mean, I look in the audience here, and everybody here can probably speak on this. We've all had our stories. But I'm going to share with you my experience and some of the crazy questions I get answered or get asked. And so let's get into this. And I just put this up. I didn't know who the audience was, but you guys know. But the main thing I want to point out here is that, you know, even our federal government has acknowledged geothermal heat pumps as the most efficient resource for space conditioning. And this slide's been around forever. But let's get into the myths. You know, the thing I always get is people call and say, well, does it work where I live? You know, I live wherever. Does it work? Does it work here? And I go, well, you know, yeah, if you live on planet Earth, it works. You know, so, but where are you from? You know, but no, really, it's amazing the number of people that ask. You know, well, it won't work here because my neighbor told me that something happened and whatever, and it doesn't work here. And there's been a lot of experiences where it didn't work, but that's another issue. That's not a location-driven issue. That's a design or installation issue. You know, and then we talk a little bit. You know, just like some of the information Bob just presented. I mean, we have a thermal resource, a constant thermal resource. What better avenue do we have to heat and cool our facilities and other systems as well? And that's one thing I always promote is geothermal. You know, there's a lot of thermal resources around, the Earth being a huge thermal resource, but there's other thermal resources too. And we're always looking for other opportunities to capture thermal energy from different systems. We recently were involved in a project on Long Island where we actually used the city water system. And I know we're going to talk a little bit about utilities later, but you know, there's utilities picking up. You know, you're selling electricity, you're selling gas, propane, whatever. You're selling energy. Why not sell thermal energy too? I mean, why not sell it? I mean, that's kind of where we see a push going on in Texas. There's a large project going on where they actually are going to be selling thermal energy, and it's the build out on that project is 7,500 homes with a district geothermal loop where they're going to sell BTUs. So I think we're in, you know, as Bob said, you know, there's a lot of barriers that we've seen, but I think I'm kind of feeling like geothermal is finding its niche finally. I think it's going to still be a slow process, but it's finally finding it. There's enough of it out there that it's finding its niche. You know, and then the question came up, is it a renewable energy resource? And I know Dan Ellis is sitting in there. He was very instrumental in getting our Congress to understand that yes, it is a renewable energy resource. You know, and again, if you just look at, you know, the opportunities that we have to reduce our energy consumption. I know we're sitting in here in a utility office. I mean, but you know, you've got solar, you've got wind where you can produce energy, but here you can go to the heart of it and reduce the consumption dramatically to prevent, you know, or to minimize the infrastructure cost of the utility company. So they're not having to build another energy plant, you know, and hopefully, you know, the electric co-ops or the electric companies will power companies will get into the market of selling thermal energy. And this is always interesting. We always talk about high performance building. You know, roughly 75% of all the LEED platinum facilities in the U.S. have geothermal heat pump systems in them. It's kind of hard. It gets difficult to get there without geothermal heat pumps. I know we did the Lady Bird Johnson Net Zero School in Irving, which is the largest zero energy school in the U.S. And it actually works, by the way. It's been online 3 years. But we went into it without even thinking about LEED. The owner said, I'm not doing LEED. Well, near the end of the project, he wanted to plug it into LEED. Well, we were 3 points shy of platinum, just doing best practices. And with the geothermal heat pumps, you get 14, 15 points pretty quick. And that gets you well on your way to getting to your platinum goal. And again, with a geothermal heat pump, for every kilowatt kWh you take off the grid, you pull 4 or 5 out of the ground and you net 6. I mean, if this was the stock market, I would invest 1 all day long if I got 5 or 6 back out. It's a very very efficient, very effective system. And our experience, to let you know, and we'll look at it here in a minute, has been, now we've done over 250 schools since 1992, primarily in Texas, but we've done schools in Phoenix and in Georgia, on Long Island, like I mentioned, and then we did a project with Harvard. So, the other phone call I get, or the other question I get, is how much land do I need? Now, I hate rules of thumb, and we all know that's what's gotten us all in trouble in this industry, is people designing off rules of thumb. And I want to caution anyone in this room not to use rules of thumb. You need to get, if you don't know how to size certain aspects of it, get some help. Pick up the phone and call. There's any of the guys in this room that work in the industry will be happy to help you, I promise. But how much land do you need to install? When I get a phone call, this is automatically what I do. I say, well, how many square feet are we conditioning? And send me your address, and we'll Google it and look at it and see. And just to get a feel for it, just to start off with, typically the amount of land you need is similar to the area that you're air conditioning. So if you've got a 100,000 square foot building, you need 100,000 square feet of land. And then the immediate question is, well, can I put it underneath the building? Well, absolutely. There's some constructability issues there, and it gets a little more tedious, but that absolutely can be done. But that just kind of gives you an idea of how much land you need. Now, when I'm talking about this aspect, I'm talking about a vertical bore system. Horizontal systems will take 4 to 10 times as much land as this, depending on where you are and, in the U.S., whether you're, in a cooling dominant or heating dominant area, that it will vary. But for the most part, that's what it looks like. And so this slide kind of shows you, you have the facility here, and you can see these shaded areas, this kind of red color, are where the well fields are. So if you were kind of start picking and laying those on top of the building, it would pretty much equal the square footage of that building. Here's an aerial of a school that was under construction, and you can see the gray areas are actually, just where they just finished drilling. That's actually bentonite, right? You can see all the well fields. Again, you lay that on top of, take those areas and lay it on top of that building. There are some 2-story components to this facility too, but you can kind of see what that might look like. And this is the after picture. You know, and when we started in '92 doing geothermal, it was driven by a client that wanted to clean his roofs off because he had facilities with rooftop units, and everywhere there was a rooftop unit, he had a roof leak. You know, after 5 or 10 years, you get, they just leak, and it's just the nature of that type of installation. But looking at this now, I mean, we didn't have the foresight, but again, you look at this now and you look, you could populate that with solar. You know, with the geothermal system, your building is solar ready, if you will, or solar friendly. And in fact, this client of ours, Frisco, is currently looking at implementing solar PV on all their campuses. And we've done 50 schools for them in the last 10 years, all geo. They're a huge proponent of geothermal. Okay, let's move on. This is a project we worked on at Harvard. It's kind of hard to see, but the geothermal well field's down here. And then here's the research facility. They put in a 24-hour research facility sitting on a hill at solid granite. And we ended up drilling 500-foot bores in solid granite. Conductivity of 2.5. You know, it was pretty amazing. And this slide here, I just used to kind of support, what I was saying about the square footage of the, the land area versus the square footage of conditioned space. And don't use this for design purposes, please. This is for a specific type of building, and it's not intended to be someone to take off and design off of. But you can just see the spacing, and people, if you put, like Dallas Fort Worth, if you use 15 to 20 foot spacing, we actually do a 15 by 20 spacing, which is 300 square feet. Well, typical building is 300 square feet at a time. So you can kind of see how this plays out. And you go on down to like Phoenix, in the Arizona market. I mean, we need 225 to 275 typically, depending on the operation of the building. You need 350, in the Arizona market. Well, again, you just go deeper. Use the same spacing, maybe a little wider spacing. But again, this slide just shows, we design with a 2-degree creep over 20 years. Okay, people always want to know, are they noisy? Okay. Actually, they're not. We do this type of installation every day. Heat pumps above the ceiling in a classroom. You don't have any issues. The only thing I've been able to detect is if you go into the, when the building is getting ready to open before there's anyone in it really, and you go into it and you stop and listen, you can hear the compressor whirring. But other than that, it's just the same air noise as you have from any other air conditioning system. And that's really all you hear. Once you put the kids in there, you don't hear anything. You hear between the rustling of the kids and all that. So, we have done thousands of classrooms with the heat pumps sitting above a lay-in ceiling, just like this lay-in ceiling. No insulation. The only thing between us and the heat pump is a ceiling tile. Been very successful. Very seldom do we ever get a complaint. And if it is a complaint, it's typically driven by the fact that it hasn't been balanced yet, and we're moving too much air, which would happen with any system. Now this is an old slide I have. I think this is from Train. Again, you guys know what's inside one of these units. And that's just a typical installation for us. Okay, the maintenance. again, one of the best resources that we have has been Frisco. When we started working with them, they had a dozen schools, and now they have 60 some odd schools. With the last 50 some odd being geothermal. In reality, geothermal heat pumps require the least amount of maintenance. Frisco, the school district itself, they have their own in-house maintenance staff. A couple of years ago in discussions with them, they came, I go check in with them on their maintenance side, and they had not added a maintenance person in 20 schools. They had needed another HVAC tech. A couple of years later, in discussion with them, they said they're now back to changing their own filters again, because they were contracting that out, but now with the staff they have, and the amount of maintenance required by the geothermal systems, that they were able to actually go back to changing their own filter. So that right there is a huge testimony. I mean, that's real input from an owner that's committed to geothermal and understands the benefits of it, and they're very open with it. And, I mean, if you guys ever want to talk to them, I can certainly hook you up with their maintenance staff. They're very free with information, as I am as well. Back in the day when I was trying to do, life cycle cost analysis and trying to figure out what the true maintenance cost was, I looked for everything, and I found this ASHRAE study that was done in, I think it was, is a date on there? You can Google it, that Project 929. But you can see geothermal heat pumps down here. If you go over to that 75th, or you can go to any column, but you can see the number of facilities. They had 41 geosystems. Anyway, 20 cents a foot, 20 cents a square foot was a maintenance cost compared to, the VAV systems, 51 cents, 52 cents. And I just typically use this slide just to show you relative, or show clients or people that have questions, just, relative difference in maintenance costs. And our experience, especially in Frisco, is this is exactly right. And they will tell you the same thing. They have 4 pipe systems that they would, we've been they try to figure and finagle any way they can to convert their existing facilities to geothermal. Unfortunately for them now, they're all populated with the schools that would be their prime candidates. Actually they're covered with parking lots, so they can't get to the, the cost now of the Borefield. It also includes the cost of replacing the parking lot. So the economics, we haven't been able to get the economics to work out for them. Some people, this is another thing. When you talk to people, I've talked to a lot of professional people and everything, and they automatically assume that you're putting refrigerant in the ground, which there are those systems. But that's not what we're talking about. Again, in our experience over the years, we simply circulate tap water, or just and then if we get into some climates where we need a little bit of glycol, we'll use a food grade glycol, which again is benign to the environment. Should it escape? I will tell you, over doing this 20 some odd years, I've only had I've had two occurrences where we've had failures in loops at the bottom of the loop at the U-bend. And it was a manufacturing defect by the same manufacturer, and it was a global issue with that manufacturer. In that season of their manufacturing, they decided to re-engineer the U-bend. And I ended up talking to the engineer that designed the U-bend, and he failed to consider the weight of the water the column of water sitting on that U-bend. He failed to consider that. He was just thinking of a horizontal pipe, basically. And I said, no, you got a 250-foot column of water standing on top of you. So they had globally failures with that U-bend designed. And then here's just a typical bore cross section of a bore. We recommend, we go 4 feet deep in our climate. You obviously want to be below the frost line. 4 feet deep is just a good place to be. I mean, that keeps you from having to do any shoring or anything for OSHA. That keeps you within those constraints, so you don't have to shore, and it keeps you out of the throes of typically, a guy with a shovel or an irrigator or a landscaper. Not always, but we all know the number one nemesis to a geothermal system is a human with some type of a backhoe or auger, or that's been our experience, or a horizontal boring machine. We had a guy in Frisco, actually, a utility contractor. We don't know whether the guy got on his cell phone or what, but he was just tunneling underneath the street. Somehow he lined up perfectly with our well field and went underneath the street and another 200 feet. We still don't know, but he just clipped every. He couldn't have lined up any better. He clipped every one of them. It's always interesting to see what happens. You bury stuff. And here's just, I just threw this in here. Again, I didn't know who my audience was going to be for sure. And I'll be happy to share and this stuff's on our website, actually, I think, and I'll be happy to share any of this data with anyone. And the mystique out there now is you have to have the tax incentives, or these things don't work. The economics don't work if you don't have the tax incentives. But then we have, in our market and where we work, our clients can't capture these tax credits. They're public, public schools or federal facilities, so they're not available to capture those. So our experience has been, I know this data is old, but this is when they switched to geothermal. This data right here is probably, in all this data from Frisco, these are the same buildings. If you look at the square footage, they'll tweak them a little bit, but back then it was a prototype building, so these are the same buildings. And you can see this was back in, I didn't normalize the data, that's just the raw cost. You can see they're within pennies per square foot compared to a 4-pipe system. And Frisco used, prior to geothermal, they were using a 4-pipe system. Now the debate always comes about on this cost, or what are you comparing it to? Because it's not like you're shopping for a car or something. Well, it is kind of like shopping for a car, I guess. Which model are you going to buy? Are you going to buy the, if you go to one dealership and you price out a car, then you're going to go to the next dealership, and the car you're going to price out is going to be the similar model. You're not going to go to Cadillac and price out a car, and then go to Hyundai and price out a car and compare. Make your decision based on. You may ultimately do it, but you're not comparing apples to apples. Is the point. You're looking at a Cadillac and a Hyundai, and they're not necessarily, depending on which models, they may not be comparable. And obviously they're not comparable in price. But for me, you know, if you're going to do a commercial grade system, what I call a commercial grade system, a 4-pipe system is more in line with a, you know, especially in the school market, they're building a 50-year building, and if you put in rooftop units, you're putting in a 15-year solution. You know, you put in geothermal, the well field or the Borefield, as Bob said, we don't know what the life is. I think the polymer itself has the HDPE, the polyethylene polymer itself has a half-life of 1 billion years or something like that. I don't know, something crazy. It doesn't make any difference. It's well beyond any of our lifespans. But you know, for us, the first schools we did back in '92 and '93, we still have not changed the equipment out yet. And we still work with that client, and we're at the mode now where we're talking about they're planning for the future about replacing those heat pumps. So I took that cost data with real energy cost off their, you know, straight from them, off their bills, and compared to a 4-pipe system, you know, you can see that, you know, it's less than a year. I mean, which those numbers reflected. And again, when I do these things, I don't normally put inflation or any escalation on them because the discussion immediately goes to, well, that's, you know, it should be 2%, not 3% or whatever. So you just run it flat, then you don't have anything to worry about. This MISD is a client of ours, Mansfield. They were doing, when we first visited with them, they said, we know you do geo, but we don't want to do geo. This is what we do. Well, they now do geo. After I used this slide, they saw my presentation at a school district conference, and a couple of the board members saw it and said, wow. And what's really interesting is, you know, I'm big on keeping things simple. You can see their controls cost was $180,000. Their lead HVAC guy says on those Vipers, they've had to go in and just screw dampers in positions where they want them because they can't keep the things calibrated, can't keep them working. Because you've got economizer cycle, you've got demand control ventilation, and you've got, you know, the sensors associated with that. They cannot keep it. They couldn't keep it calibrated, which that's a whole nother discussion. This is a school that Bob showed the slide on, Richland Middle School, where we added 20% more area, and that's the same slide that he was showing you. I kind of view this, and this was done in back in the summer of '94. This to me is like the poster child for geothermal, and I've always used this slide. Here's one that we did later. You know, now the industry always wants to see kBTUs a square foot. They don't want to see dollars. So you can see that this school was a Frisco school that we converted back in '05, '06 to geothermal. I dropped from being in the 60s kBTUs a square foot to being down in the 30s. Again, all testimonies to what we're doing. Here's graphically, we've added more schools. Again, that's dollars per square foot. So all of this just kind of shows high schools. And I will tell you what the trend that we have seen is that the more our facilities use, the greater the energy savings. Our elementary schools, because they're pretty much a 8 to 4 operation, see 30% energy savings across the board. I mean, you can almost take that to the bank. A middle school, depending on the district, will see anywhere from 40 to 50% savings. High schools will be 50 to 60%. And we have it's all documented, and we have the real data for it. In fact, the school district has their own presentation that they sent to the Attorney General in Texas to have it audited. Did you have a question?
Is that the total energy, lighting, everything?
That's total energy.
Meter.
Total meter, that's just straight off the meter, yes sir. Okay, the other thing is they say, and this came up recently by someone promoting geothermal. They say, well, after 20 years, you're going to have to replace the well field because it becomes saturated. And I'm going, wow. Okay, so what are we doing here, guys? Yeah. 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 But again, yeah. Change the dirt out? Yeah. So, like I said, the polymer has a half-life of hundreds of years, It's got to be designed and put in right. That's the main thing. It's got to be designed and put in right. I mean, the number one problem that we've had and I've witnessed in the Dallas market and in some other markets where I've gotten phone calls is you've got a person, how can I say this politically correct? Yeah, a person with lots of money. Okay, builds a nice 20,000 square foot bungalow, and they're going to put geothermal in it. So they call somebody, and then they end up with somebody's brother-in-law. And so they put the thing in, and then it doesn't work. And then that's when we get the phone call. And there are contractors. We have one contractor in Texas that has an inventory of these problem childs. And there's another contractor that makes a living fixing his problems. I mean, you can anyway. That's the number one question I ask when I get a phone call on a big house is, who put it in? And if it's this guy, I just immediately say, here's who you need to call. Anyway, but again, if it's designed and installed properly, it'll last indefinitely. I mean, the whole thing on geothermal and the Borefield and all the mystique that people kind of put around it is, I mean, it's no different than selecting a cooling tower, a chiller, a rooftop unit. If it's missized, misinstalled, it's not going to work. I mean, it doesn't work. And we all know that the new technology, geo being new to most people, is, I mean, if you guys remember back in the days when we got these programmable thermostats, So you put one of those in your house and the tech would come out and immediately if you had any problems, say, well, it's that thermostat. You got to replace that thermostat. And that's I kind of equate some of our pushback to that as well. Okay, can any contractor install it? I mean, you really need to utilize ICSPA certified people. That's not going to say that you're not going to have an issue, but at least they've been exposed to it, and they've been to class, and they've at least had the foresight and the drive to go learn about it rather than just Google it online or something, or watch a YouTube or something. But you really need. We always mandate. I mean, we go even further. We actually list approved contractors on our projects in markets where we know them. We will. Others can come in and bid, but because we're dealing with public money, but we will list 4 or 5 contractors that we know will do a good job. That's, the drillers, the loop installers, and the mechanical contractors. So again, you need to stay with knowledgeable people. I mean, you don't. It's just like with a chiller, you don't hire a residential contractor, mechanical contractor to come work on your chiller. Same thing here. You don't hire, a residential contractor that it's never seen geothermal before to put in your geothermal system. Because they're all going to look at the dollars and cents. Again, engineers. I can't tell you how many times I've gotten a phone call from an engineer that says, well, I mean, we use 250 feet a ton. That's what it is in this market, and it's heating up. And I'm going, well, what'd you hook it up to? Well, you've got it hooked up to a building that's running 24 hours a day. Well, no, it's not going to work. I mean, what's that 250 feet a ton equate to? I mean, what kind of build? I mean, designing a geothermal system, the Borefield side of it, reminds me of the days when we used to do thermal storage system. You got to look, you're talking ton hours. You're talking hour. You're talking duration of heat load or heat gain or heat loss, if you will, out of a building, and you've got to equate those. You know, and as Bob mentioned, somebody needs to be watching them that knows what they're looking at. You know, we for our team, we don't allow anyone to cover up. We'll monitor the drilling, but then when we get into headering, we don't let anything be covered up until we've inspected every joint. You know, and our office only allows butt fusing. We've had issues with socket. That's just our preference. I mean, I know there's a lot of people who've been very successful with socket fusion. We just haven't had that experience. But again, ICSPA certified designers. These engineers need to go to those classes. They need to understand that it's not a condenser water system. There's other aspects of that design. You've got velocities you've got to be very aware of, not just for operation, but for purging. When you're selecting that pipe size, you've got to know that you can maintain those velocities and achieve those velocities to adequately purge it. It's not hard, just to be honest with you. Now, sitting on this side of it, designing a geothermal system is one of the easiest systems to design, hands down. Once you get your test bore, you use whatever software you're comfortable with. Garen and I had this discussion last night. We use different software, and so he's wrong, but that's okay. Yeah. So, but I mean, use one of these softwares that has the algorithms in it built into it that are tested and proven, and know how to operate the software. You got to understand what you're inputting. But it's, and these are the things. I mean, the big things that we see again are, unfortunately, you get the calls on the problem projects. I've gotten calls on projects that were missized, and they were certified people. So I mean, people do make mistakes. I'm not saying just because you get the ICSPA guy that it's but you at least got a chance rather than some guy that's doing his first job. And I'll tell you, in an engineering office, because before I got into my own business, I worked for an engineering firm where we had 120 engineers, and I was one of the department managers. I mean, you get something that's quirky, you always give it to the young guy, let him figure it out, And then he's there 2 years and gone somewhere else, and so these are just some points about it. But I mean, my point is that the myths are just that, they're myths. I mean, people just misconceptions because people of influence. What I've seen, people of influence or school districts. I mean, and you guys know. I mean, our community's a small niche. You go to any community like school districts, it's a niche. Word travels fast. I mean, if a school district puts in a system, whatever, or uses a new whiz-bang outside air system or something, and it doesn't work, I mean, news travels fast. I mean, the bad news travels faster than good news, unfortunately, and that's true with anything, I mean. And that's not our friend. But, I mean, again, it's got to be, it's got to be designed right, it's got to be put in right. If those two things happen, I mean, people will have a positive experience and be our ally. And I don't get a lot of pushback now, but I really think that with this utility, selling thermal energy, this this stirring out there in the geo community. I think we're going to see a lot of activity on more of the district type systems. Because I think that's where I think that people are realizing this can be a utility. So, and these are just old slides I just put at the end. You know, I always like that picture. Was it Joplin, Missouri, where they show that slab with that? You know, the whole town got blown away, and there's this one house with the geo unit still connected to the headers. I won't get into that. Anyway, but it's been, you know, I've been the naysayer. When I first got into this, I was forced by a client, kicking and screaming, saying, "You don't want to do this, you know. You're making a mistake." And he said, "Yeah, I do." And he took me down to Austin and showed me what they were doing, and then he took me up and had me talk to Phil Shane. He said, "Now you figure out how to do this." And that's when I called Bose. Dr. Bose got his program, his little basic program, and played with it a couple of days and sent it back. And it was like $500, and I sent it back to him. And he called me personally and said, "You didn't like it?" I said, "No, it just doesn't work for me. All it did was one system." And I was trying to do, you know, I was trying to do a whole school. This little basic program was really for a house, I guess, back then. That was the infancy of programs. So, but that's all I have. Any questions? Yes, sir.
I just have a quick question on seismic activities. You know, I've gotten questions on, well, especially in Oklahoma now, what happens with earthquakes to the system. Are they rated or designed to withstand a certain earthquake on the Richter scale? Or?
No, I mean, HDPE piping is what is required by code in seismic zones. I mean, the net zero school that we have in Irving is within 5 miles of where all that earthquake activity's been in Texas. I mean, you can you can stretch this stuff.
Stretch it 10 times its diameter before it fails, and so if you've gone that far, you probably don't have a building to worry about anyway.
Yeah. Yeah, You're looking down on your building.
Yeah.
So never seen a loop fail because of what somebody would call an earthquake?
No.
California already.
I mean, HDPE pipes. Stormwater systems all have to be HDPE pipe in seismic zones. Natural gas lines are HDPE. They're medium density, right? Yeah, gas lines are medium density polyethylene, and we're using high density. Yeah.
Is there any research on, say, underground water pockets and utilizing underground water opposed to a closed loop system?
You mean like a well? You mean like a water well?
Like a water well.
Are you talking about a reservoir, or like an aquifer or something?
Yeah, any dead line.
All those, yeah, that's done, yeah, absolutely.
Do you have to, if you have some water, like...
Water's our friend.
Well, in the area where I live, the underground water is very contaminated due to 100-year-old coal mines, things like that.
Yeah.
So you got high mineral contact, corrosiveness, any issues?
It won't affect the pipe. The only thing I've seen affect the pipe so far is we did a project. We have a project that we did, and the owner changed the use of it. So we had to go back in and add some bore fields or extend the bore fields because the owner changed the way he was operating the facility. And we dug up some pipes, and it was pit. And when they went back to start tying onto it, the rollback was all pitted, and we're thinking, well, you got water. You had water, moisture, and come to find out there had been a steel mill there at one time, and there was some oil. Some hydrocarbons got dumped in that soil that we didn't know about, and it interacted with the pipe. I'm still not sure what the long-term, the pipe's okay. I don't know long-term wise what it will actually, if it shortens the life of the pipe or it just does its initial pitting. Somebody else in here may know, I don't know. We had to pipe people out and everything else. Gary, do you know anything? But that's the only thing I've ever seen react, was we had a site with no one knew. They did a environmental impact study, but that didn't show up in it. And so come to find out, and I didn't find out till after we'd done all this and was talking to one of the guys there in the area. He said, oh yeah, there used to be a steel plant there. And I'm thinking, well shoot, so we're just assuming they hydraulic oil saturated into the, migrated down into the ground. But again, we're benign. I mean, I don't know anything that will really, I can't think of any chemicals or any, that really.
I wasn't talking about the effects of the underground water on the pipe itself. I was talking about collecting water for using it for the heat transfer and then returning it.
Yeah.
Pump and dump.
Yeah, pumping, yeah. That's been done a lot and been very successful. You just got to be careful and understand what you're going to precipitate out of that water when you put 10 degrees on it. Yeah, but you can always put a heat exchanger in. And there's options on the heat exchangers. Yeah.
There are some manufacturer specifications of the type of water to use. You can't just use every salty, acidy type of water in the equipment.
Right. Yeah. You gotta. Yeah. You can get some high. The manufacturers will give you some of them have options for the heat exchanger material where you can get a little more robust heat exchanger, possibly that might be suitable for that water quality. But you would need to explore that with. You need to get the water tested, then you need to get with that equipment manufacturer and look at look at what you're dealing with there. But again, I mean,
So it'd be better just to drill through, install a loop, and
well, the thing is when you do the pump and dump, that's an open loop system. So you've got the energy that you have to expend to lift that water is. Versus a closed loop system where you don't have, the lift of the water is out of the equation because it's closed. You're just circulating. So you need to look at the economics on that side too. Understand, because I've looked at several projects where guys they had a 1,400-foot well and they, to get to an aquifer and they wanted to lift the water, and so they've got 200-ton system and you got to put a 75 horsepower pump on this thing to lift it to get the flow. And so you start looking at your efficiency, your EER of the system, and you end up down in single digits real quick. And it's just not viable.
One of your slides showed that you could get 8 to 14 lead points for a ground source system, and this is to the directors, Biggs, Bud, and Bob, and staff. When you go to the renewable section in lead, ground source isn't considered a renewable. Right? So we definitely need to talk to them about that and change their mind.
Yeah, we do. Yeah. Now the chips, there's another rating system that we're using now for school, collaborative for high performance schools. It's called, the acronym's CHIPS, and they do list geothermal. But they do list geothermal as renewable. They got it with wind and solar and everything else. So those guys listened. Lead guys that's a different breed.
Why isn't ASHRAE promoting this as much as they should?
Why isn't ASHRAE promoting it?
We have an active committee, 6.8, that's there all the time.
Yeah,
so in our publications, it's out there all about it. So it's just like any other heating and cooling system to ASHRAE. If you want to know about this, you go to that subsection.
I guess the other reason is the industry is very branching into the other types of devices.
Well, ASHRAE put geothermal in their headquarters, and they have that whole study.
Yeah.
And you talk to Dan Ellis; he knows all about it. The VRF and the Geo. I think the VRF guys are on their third set of equipment or something, or second set, or.
well, they've been revising our controls, trying to
Yeah.
figure things out.
And they still, they can't touch it. They can't get there. It's what, still 30% or something off?
It's like 47%.
Was it that much? Yeah. So, yeah. But ASHRAE is, ASHRAE is, you know,
But they haven't come up with any standards on it yet.
yeah, ASHRAE has standards.
Yeah, oh, yeah.
Oh, yeah.
And they have testing standards, everything, so. And we're having the Canadian Standards Association, which is binational, US and Canada, it's fully in there. So it's implemented across the board, across the schemes on everything. And we use similar stuff. And to be honest with you, what we start doing is molding what ICSPA has and ASHRAE has and other stuff into the Canadian standards.
Yeah.
So you'll see all that.
Yeah. 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 And the last point I want to make involves commissioning. And this has come up big time for us across the board, is calibration on controls. These controls companies will tell you, well, my sensor's 20,000 ohms, 30,000 ohms, it doesn't need calibration. That's not true. That's not true. You need to check, and they need to be checked, because where I first became aware was we had a building, one of these Frisco schools, the exact same building as another one, same temperature set points, and you go in it, and the well fields are, after 10 years, are running in the 90s. You're going, what? And the other one's running in the low 80s, and you're going, what's going on? And so we get out there and look. Well, it's 5 degrees out of calibration. Stats showing 77 and it's 72 in there, and this thing's running, comes on at when it's enabled and runs all day long, trying to get to 72, which is now really 67. And it wasn't designed to do that. I mean, and so, but just every control company will tell you. I just had Honeywell tell me that in New York. Oh, we use the best sensors out there. They're 30,000 ohm or whatever, and I'm going, and sure enough, they said, we've never calibrated these. And I said, well, you're going to calibrate these. And after it was over, they said, wow, we didn't know that. We've always been told. The head office says they don't need to be calibrated. So that's my recent lesson learned. And so that's the reason I try to stay with simple controls. When we're spending $60,000 for controls, and the other guys are spending 180. That means you got 3 times the problems with controls in my book. And at 3 times 60 is 180, right? Yeah. So that's the way it works. Yes, sir.
The cost factor, is it going still down, or is it now stagnant and going up?
The system cost? It's interesting. In fact, I pulled some stuff in our office yesterday. I was talking to some of our guys. We have seen the general contractors that have done a lot of our geo schools are saying it's come down about $1 a square foot in the last few years. It's actually cheaper than chill water systems now in our market. But
That's high ground temperatures.
huh?
That's relatively high ground temperatures.
We're 70 degrees.
Heat rejection.
Yeah, 70, 72. But we pulled the last several projects, started looking, and the price varied $5 a foot. And we're just kind of going, it just depends on when you hit who, all the projects are within budget, but one may be, you may have one at $18 a foot and the next one may be 23, and there's no rhyme or reason. But, for us, the drilling cost is, our experience has been, if you were to call me on the phone and say, what's the geothermal cost? I would immediately tell you it's around $20 a foot if you're in the Dallas area. $12 a foot is the air side, the unit and the air side, and $8 a foot is the Borefield, the laterals, and the headering inside the.
Was that the same or a lot more 2005, 2006, or 2010? Was it the same like 2020?
No, 2000, that slide I showed, I think it was like 13 or 14 bucks in 2004 or 5. Yeah, it's come up a little bit. It seems to, honestly, it seems to have plateaued. Okay.
Last question. Lay aside availability of land, horizontal compared to vertical. Anything that makes one better over the other?
I mean, I mean, when you go, the deeper you go, the more constant the earth temperature is going to be. But it takes a lot more land. I mean, you said lay that aside, but I mean, literally, I mean, your results are more predictable going straight down. I mean, and there's a lot of horizontal systems out there. I mean, it's actually, if you've got the land, I would look at both of them. If you've got the land, I would explore both of them. Absolutely.
What's the benefit from trenching as opposed to going straight down? Does it, I mean,
It's just-
it's usually cost more to trench.
Well, I mean, I don't know what.
That's where you make the decision.
Yeah.
Just purely on cost.
Really on cost.
But isn't there a greater variability?
Depends on efficiency.
Yeah.
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 Don, what about moisture? Going straight down, you have better control of your moisture.
Yeah, moisture. I mean, like I say, and moisture is our friend. If you can go vertical, you have the better chance of getting into some maybe going through a vein of water, or you get into some dampness in the soil. Absolutely, yeah. The water's our friend. I mean, I will tell you though, as a designer, when I get a test well results back, and I know what the conductivity's been in that area, and this just comes from experience, and I see one real high, I'll automatically back it back down, because if that moisture goes away, I don't know they say, well, we hit a pocket of water at 75 feet. I don't know that it's going to be there. I mean, somebody may do something around you and alter the course of that. So you got to be, as a designer, you need to be, unless you need to know what that water source is before you trust it.
I have one question. Grout. All the boreholes you put in, I know you've done a lot of them.
Yeah.
Different types of grout.
You really want to go there?
I just, general.
Okay, well, it depends on your soil type. First. Okay, that's the first thing you got to look at, is your grout compatible with your soil type. And then you need to look at your conductivity and your diffusivity. I'm a proponent of I use just standard grout, 0.4 or 5, whatever, conductivity. Yeah, BH20. And the reason, and I have done some thermally enhanced grout. I mean, I've priced jobs out, and there's really no cost. I mean, yeah, you can reduce some bores, possibly, but the cost of the grout and the headaches you get from you don't get them now. The drillers now have the machines, the grout machines, to deal with it, but early on, they just pitched a fit. But you got to be careful in your grout selection. If your soil has a thermal conductivity of 0.8 and you're putting in a grout at 1.2, it's kind of like putting a Corvette engine in a Volkswagen. I mean, what have you accomplished? Yeah.
There's some research on the website also about that, both for vertical and horizontal systems.
Yeah. I mean, I would rather the soil act as a thermal wick rather than us trying to push it. I'd rather, heat goes from, how heat transfers. So, I mean, I would rather let the soil pull it away than force it into the soil. That's my 2 cents. Yes, sir.
Your slide about the myth of heat saturation of a well field. What are the considerations when you're putting a system in where cooling degree days are much higher than heating degree days? I mean, here in Oklahoma, we're a little more even. We're a little higher on the heating degree days. And what about when you go further south, like down in the South Texas, where your cooling degree days are much higher? Are there any considerations you have to do with that well field?
Well, I mean, again, you model your load and you know your soil conditions and you know your monthly load profiles. And so, yet you end up with more foot per ton of Borefield. Like the jobs that we did in the Phoenix market, again, there we use thermally enhanced grout because of the dryness of the soil. The bentonite would have, cracked up over a period of time. But it just takes, typically you end up with bores further apart and deeper and more of them. And then you have to look at the economics. And then that first slide, does it work here? I mean, obviously the technology will work anywhere unless you're sitting on top of a cavern or something. If you drill down 100 feet and then there's a void 400 feet or something, well, you have to rethink what you're doing there, but the economics have to work. We're in Texas, our drilling cost is such that we've been very successful. I know that I'm looking at a deal in California, and their drilling cost is like 3 to 4 times what we're paying. And then you also have this additional chart that you have to haul everything off, and it's like that adds another 4 or 5. I mean, that cost is almost as much as our drilling cost, just to get rid of the spoils, because you can't. They're real wiggy about all that stuff. So I don't do a lot of work out there. I don't like those people. Yeah. I always refer them to Lisa. Absolutely. All right. I'm done.
Thank you.
Mm-hmm.